NFPA 780, standard for the installation of lightning protection systems, provides guidance on the installation of lightning protection systems. NEC 2002 Article 250.60 states that in general, metal structures mounted on or adjacent to a building should be bonded to the building's grounding electrode system. Article 250.106e says service equipment and other electrical equipment shall be bonded to the grounding electrode system. Based on the NFPA 780 and NEC 2002 requirements, it is recommended that the ornamental copper structures and the rooftop be bonded to the grounding electrode system of the dwelling. This is because firstly, the copper structures are mounted on top of the building, making them exposed to lightning strikes. Secondly, lightning can travel through metal structures, including ornamental structures. Thirdly, bonding the structures to the grounding electrode system provides a path for lightning currents to safely dissipate into the earth. The copper structures should be bonded to the grounding electrode system using a suitable bonding method, such as firstly, a copper bonding strap. Secondly, a grounding rod. Thirdly, a concrete encased electrode. The bonding method should be designed to provide a low impedance path for lightning currents. Firstly, the bonding strap or grounding rod should be sized appropriately based on the potential lightning current. Secondly, the connection point between the bonding strap and the copper structure should be protected from corrosion. Thirdly, if the structures are not grounded directly to the grounding electrode system, they may be bonded to a lightning protection system if one is installed. By bonding the ornamental copper structures to the grounding electrode system, you can help protect the dwelling and its occupants from lightning strikes. The purpose of bonding is to create a low impedance path for fault current to return to the source, allowing the overcurrent protective device to operate and clear the fault. In the context of lightning protection, bonding is used to connect different metal parts of a structure together to minimize potential differences during a lightning strike. This helps to prevent dangerous sight flashes and stop potential hazards. Grounding, on the other hand, is the connection of the electrical system to the earth. The grounding electrode system provides a path for fault current to flow to ground, which helps to stabilize voltage and prevent electrical shock hazards. In the context of lightning protection, grounding helps to dissipate lightning energy into the earth, reducing the risk of damage to the structure and its contents. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or concrete encased electrodes. These electrodes are connected to the electrical system using a grounding electrode conductor. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The grounding electrode system should be installed in accordance with the requirements of the NEC, specifically Article 250. Proper bonding and grounding are essential for electrical safety and lightning protection. Bonding helps to minimize potential differences and prevent side flashes, while grounding provides a path for fault current and lightning energy to dissipate safely. The combination of bonding and grounding creates a safe and reliable electrical system. In the case of the ornamental copper structures, bonding them to the grounding electrode system provides a direct path for lightning energy to flow to ground. This reduces the risk of damage to the structures and the dwelling, as well as the risk of electrical shock to occupants. The bonding connection should be made with a copper bonding strap or grounding rod that is sized appropriately for the potential lightning current. The connection point should also be protected from corrosion to ensure a long-lasting and reliable connection. Remember to always consult with a qualified electrician or lightning protection specialist to ensure that the bonding and grounding system is installed correctly and in accordance with all applicable codes and standards. Lightning protection systems are designed to protect structures from damage caused by lightning strikes. These systems typically include air terminals, conductors, and grounding electrodes. Air terminals, also known as lightning rods, are installed on the roof of the structure and are designed to intercept lightning strikes. The conductors connect the air terminals to the grounding electrodes, providing a path for the lightning current to flow to ground. The grounding electrodes dissipate the lightning energy into the earth, reducing the risk of damage to the structure. NFPA 780 provides detailed requirements for the design and installation of lightning protection systems. The standard covers various aspects of lightning protection, including air terminal placement, conductor routing, grounding electrode selection, and bonding requirements. It is important to follow the requirements of NFPA 780 to ensure that the lightning protection system is effective and reliable. The NEC also includes requirements for lightning protection systems. Article 250 covers the grounding and bonding requirements for electrical systems, including lightning protection systems. The NEC requires that lightning protection systems be bonded to the building's grounding electrode system. This helps to ensure that lightning currents are safely dissipated into the earth and that potential differences between metal parts of the structure are minimized. In addition to NFPA 780 and the NEC, there may be local codes and regulations that govern the installation of lightning protection systems. It is important to check with the local authorities to ensure that the installation meets all applicable requirements. When designing a lightning protection system, it is important to consider the specific characteristics of the structure and the surrounding environment. Factors to consider include the height and shape of the structure, the type of materials used in construction, the soil conditions, and the frequency of lightning strikes in the area. A qualified lightning protection specialist can assess these factors and design a system that is appropriate for the specific application. Regular inspection and maintenance are essential for ensuring the effectiveness of a lightning protection system. The system should be inspected annually to check for damage, corrosion, and loose connections. Any necessary repairs should be made promptly to maintain the integrity of the system. Lightning protection systems can provide significant protection against damage caused by lightning strikes. However, it is important to remember that no lightning protection system can guarantee complete protection. Lightning is a powerful force of nature, and there is always a risk of damage, even with a properly installed lightning protection system. By following the recommendations of NFPA 780, the NEC, and local codes and regulations, you can minimize the risk of lightning damage and protect your property and occupants. The grounding electrode system is a critical component of any electrical system, providing a path for fault current to flow to ground and helping to stabilize voltage. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or concrete-encased electrodes. These electrodes are connected to the electrical system using a grounding electrode conductor. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The grounding electrode system should be installed in accordance with the requirements of the NEC, specifically Article 250. The NEC specifies the types of grounding electrodes that are permitted, as well as the minimum size and installation requirements for each type. Ground rods must be at least 8 feet long and must be driven into the ground so that at least 8 feet of the rod is in contact with the soil. Ground plates must have a surface area of at least 2 square feet and must be buried at least 30 inches below the surface of the earth. Concrete encased electrodes must be encased in at least 2 inches of concrete and must be located within the bottom 20 feet of a concrete foundation or footing. In addition to the grounding electrodes, the grounding electrode system also includes the grounding electrode conductor. The grounding electrode conductor connects the grounding electrodes to the electrical system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC specifies the minimum size of the grounding electrode conductor for various sizes of service entrance conductors. The grounding electrode conductor must be made of copper or other approved material and must be installed in a manner that protects it from damage. The grounding electrode system must be properly bonded to the building's metal water pipe, if available. This helps to ensure that all metal parts of the building are at the same potential, reducing the risk of electrical shock hazards. The bonding connection must be made with a bonding jumper that is sized in accordance with the requirements of the NEC. The grounding electrode system should be inspected regularly to ensure that it is in good condition and that all connections are tight and corrosion-free. Any necessary repairs should be made promptly to maintain the integrity of the grounding electrode system. A properly installed and maintained grounding electrode system is essential for electrical safety. It provides a path for fault current to flow to ground, which helps to protect people from electrical shock hazards and prevent damage to electrical equipment. It also helps to stabilize voltage, which can improve the performance of electrical equipment. In the context of the ornamental copper structures, bonding them to the grounding electrode system provides a direct path for lightning energy to flow to ground. This reduces the risk of damage to the structures and the dwelling, as well as the risk of electrical shock to occupants. The bonding connection should be made with a copper bonding strap or grounding rod that is sized appropriately for the potential lightning current. The connection point should also be protected from corrosion to ensure a long-lasting and reliable connection. Always consult with a qualified electrician to ensure that the grounding electrode system is installed correctly and in accordance with all applicable codes and standards. Remember to always follow the electrical code and that you are responsible for your own actions. Always check the latest edition of the electrical code.